Welcome to Brain Vision.
So here we're going to draw the free bar diagram for the falling rod. Let's draw our axes. This would be the rod here. At the center of mass would be the force of gravity. The rod would have a length of L. Here would be force normal. This would be force of friction. And we can say that this is an angle phi. And so we can, for part A, we can say that the axis of rotation would be coming out of the paper at the point of contact with the floor. We could say that here only gravity actually creates torque, and then we can simply say that we're going to apply to, in order to evaluate the net torque, we can say that counterclockwise is positive. So we can say that the sum of the torques is going to equal the moment of inertia times the angular acceleration. This would equal negative mg times 1/2 times L cosine of theta. So that would be the length. And then we can simply solve and say that the net torque would then be equal to 1/3 times ml squared times the change in angular acceleration, which would be the derivative of the angular velocity with respect to time. We can then say that negative 3g over 2l cosine of phi would equal the derivative of the angular velocity with respect to time. And this would be equal to the derivative of the angular velocity with respect to the change in angle multiplied by the change in the angle with respect to time. So then we can rewrite this and say that negative 3g over 2l cosine of phi would then be equal to the change in the derivative of the angular velocity to phi times the angle phi. And rewrite and say 3g over 2l times cosine of phi times d phi would be equal to negative 1 times the angular velocity times d omega. Now we integrate. So we can say 3g over 2l integrating from pi over 2 to phi times cosine of phi d phi would be equal to negative times the integral from 0 to omega times omega d omega, and this would give us 3g over 2l times sine of phi minus 1. This would equal negative omega squared over 2. And so omega is simply going to be equal to the square root of 3g over L times 1 minus sine of phi. This would be our final answer for part A. Now, for part B, we want to find the velocity, linear velocity at 0, at a phi equaling 0. So we can say that v is going to equal the angular velocity. The linear velocity equals the angular velocity times L, and this would simply be equal to square root of 3g L 1 minus sine of phi. So when we want the linear velocity at phi equaling 0 degrees, this is simply going to be equal to the square root of 3g GL. This would be our answer for part B. That is the end of the solution. Thank you for watching.